analysis on water surface profile generated from hydrodynamic modeling with respect to the inaccuracy of cross sections data. And I'm Soysa, and my co-author is Hydrodynamic. And so before we get into the deep in detail of this particular presentation, I would see that you should be familiar with at least 4 key words in this particular research topic. The first one is sensitivity analysis, the water surface profile, and hydrodynamic modeling, and the inaccuracies of cross sections data. So let me begin with hydrodynamic model. So what does it really mean by a hydrodynamic model? Is a closed simulation of a water body, either steady force simulation or unsteady simulation. So where you will look at a water body and identify what are the flow scenarios and the flow properties. So you are going to do it through the hydrodynamic model. And the second thing is the water surface profile. Why do we have to develop hydrodynamic models? So main objective of a hydrodynamic model is to first identify and study the flow scenarios, and then to predict some certain cases where for engineering investigations. So what it really matters in here is apart from the flow properties, water surface profiles is a key parameter where you would look at if you are considering about flood delineation and identified of flood plains and certain spatial extent of the floods. So there, the water surface profile of a water body for a given condition is very much important. So then how we are going to develop the water surface profiles? So basically, before we are developing a hydrodynamic model, there are 3 major data that you should concern. First thing is the topography or the geometric data, then the flow data and the boundary conditions. So if you consider the geometric data, apart from the surface roughnesses, the main key parameter is the cross sections data. So in reality, it is very difficult to get a accurate cross sections data. Why the cross sections data is time dependent. With the time, the previous cross sections data may not be still valid. So therefore, inaccuracy of the cross sections data but actually play a major role in the hydrodynamic model. So what I'm going to study in this particular project is how this inaccuracy of the cross sections data is going to affect for the results that you generate from the hydrodynamic model. So in this case, the results means here I have focused only about the water surface profile, not the other flow parameters. So how I am going to study about the inaccuracy of cross section data effectivity on the water surface profile. So therefore, I am going to continue a sensitivity analysis where I am going to differentiate or deviate the cross sections data and see the repercussions and see the results of the water surface profile generated from the hydrodynamic model. So having this idea about the main key parameters or the key area, my objective of this particular research topic is to study the influence of inaccurate cross sections data during a hydrodynamic model development towards the model performance and the results generated from the generation of the water surface profiles. So, and here I'm not going to only do a qualitative assessment, I'm going to quantify how this effect is really how this variation of the inaccurate cross sections data affects the water surface profile. So let me begin with my research project outline. I have a methodology, then the analysis part, then through the analysis the results develops and the conclusions. So let's see how what am I going to present under the methodology. Under the methodology, I need to select and develop a hydrodynamic model, and then I have to think about a method how am I going to deviate the cross sections data in order to produce inaccurate cross sections data, and then I'm going to continue some scenario modeling in order to assess the sensitivity analysis. So then the analysis part, in the analysis sections I'm going to consider percentage of discrepancy, the variation I'm going to quantify, and then the percentage of water surface increment. So depending on your variation of the cross section, either your water surface profile can be have a imply you a positive increment or the negative increment, and then I'm going to quantify. Therefore, I will come up with a percentage value and the sensitivity analysis. Then how I'm going to present the results. The results I'm going to concern about the magnitude of the percentage increment and the location of discrepancy. That means you may be considering a variation at a particular point, but once the result is there, you may the water surface profile may be affected at another location, or not, apart from the varied point of the cross sections, the results will be affecting at another location. How then I'm going to consider that, and then overall, apart from considering one particular location as a whole water body, or whatever the interested area during the model development, there will be a water body or a stretch of a water body. How I am going to come up with a mean ratio of absolute errors. So then I will be able to produce some conclusions regarding this effect of inaccuracy of cross sections data. So let me begin with the methodology part. Under the methodology, I need to select a hydrodynamic model, then to develop it. Then how am I going to make inaccurate cross sections data? I have a cross sections data. I am purposely going to make them inaccurate by giving a percentage of discrepancy, and then I will describe what it means by positive and negative percentage discrepancy and scenario modeling. So let me begin with the selection of hydrodynamic model. So I have selected hydrodynamic model HEC, that means Hydraulic Engineering Center River Analysis System. It's a freely available software developed by the US Army Corps of Engineers. And why I have selected this particular software is, it is one thing, it is freely available, it is hugely used for the academic purpose and research purposes. And the second thing is, you can easily simulate one-dimensional hydrodynamic models. The matter is, I'm only considering the flow properties when you consider the flow direction, rather than the lateral directions or the Z direction if you consider a wave. So hence I am only considering the 1D flow direction methodology. So one-dimensional modeling can be easily done using HEC software. So because of that, I have used it. And then, so then the selection of a hydrodynamic model is described for you. Then the development of hydrodynamic model. In this particular project, I have not actually developed models, but for my previous research studies in 2010, I have developed a Kaluaya hydrodynamic model, and my colleague, who is a co-author of this particular paper, have developed a Valley-Pan hydrodynamic model. So both of them are, both of those projects are really engaged with the industry. The first thing is to do with the Colombo-Katunayake Expressway at Kaluaya intersections, and the second thing is to come up with a stormwater management system in river planning for southern transport development project at Valley-Pan intersections. So therefore, I am not going to develop right from the scratch. I am going to use already developed model from myself and the Galahena to see how this inaccuracy of cross sections data will be affecting on the water surface profile. So if I am going to brief you about the Kaluaya model, I am going to study about 11.3 kilometer of a Kaluaya model, which is a branch of a Kalani River. And for this development of model, I have put 25 number of cross sections. Those are actually measured cross sections. And then you can see for 11.3 kilometers, only having 25 numbers of cross section is insufficient. So therefore, during the model development, I have interpolated the cross sections. And it covers a catchment area of roughly 55 square kilometers. And this one will give you the GUI, graphic user interface of the HEC software of the Kaluaya hydrodynamic model. And about the Valley-Pan model, it is something comparatively smaller, 2.6 kilometers in Valley-Pan model, a stretch of a Bentota River. But for a 2.6 kilometer stretch, Galena has 50 number of cross sections, so comparatively much higher number of cross section per unit stretch. But in this particular case, the catchment area was something much larger than the Kaluaya model. So this is the GUI interface, GUI